Let us start. I'll just introduce myself. I think both of us are giving this talk today. I'm Anirudha Jadhav. I'm an engineering leader at Amazon. Primarily been working on OpenSearch before OpenSearch and Solar and Lucene for over 10 years.
Yep. Hi, I'm Shenoy. I've been working on OpenSearch, different projects, multiple plugins, and also been part of some of the OpenTelemetry projects from the OpenSearch side. So this includes OpenTelemetry Collector for OpenSearch Exporter. And also I'm the maintainer and approver for the OpenTelemetry demo itself.
So for the purpose of today's talk, the main focus is going to be if you're using OpenSearch for observability. There are many ingestion systems, pipelines out there, like which is the open source way that you can complete your ingestion story at all layers, like metrics, logs, traces, and how do you use everything together, and what is a complete story for observability. I think we'll drive through use cases, setup, and work through examples of how you can reach. We'll start with some pieces of instrumentation. How do we instrument, what libraries you use? And from there go with more detailed systems like eBPF and how they work with OpenSearch and how we can use them to solve issues that could not be solved in a particular way. And while at it, we take a look at log analytics with OpenSearch. So from an instrumentation standpoint, you have your code base, which is in different languages, different platforms. OpenTelemetry gives you a very vendor-neutral way to instrument data. That's the primary piece of OpenTelemetry. If you go to the website, you'll know from different languages, different platforms, you'll have SDKs, instrumentation, how you can add for metrics, logs, and traces. Generally, when you think about demoing or showcasing OpenTelemetry, you start with OpenTelemetry demo. OpenTelemetry demo, it's effectively a realistic shopping website which simulates data coming from various different services that may be used to power your website. So let me showcase a demo architecture. And we'll be primarily basing our demo on real-world examples from OpenTelemetry demo as a use case. So OpenTelemetry demo runs a shopping site which has a checkout service, a front end, a cart. All these services run live with a load generator, which you can simulate traffic, or you can go to the website and track it. As you ingest data from OpenTelemetry, the instrumentation of all of the microservices and all the services in OpenTelemetry is done using OTel SDKs. That instrumented data goes into OpenTelemetry receivers and processors, and from there it can go to Prometheus, Jaeger, or OpenSearch. So today we'll see this stack and how you can use an observability solution in OpenSearch with this stack, and where the pitfalls or limitations of these stacks are and how we can solve them. So as data is coming into OpenSearch, primarily if you want to explore or work with it, we land into OpenSearch dashboards. In OpenSearch dashboards, starting 3.3, this is going to be the default interface. These interfaces will start having use cases like observability, security, search. OpenSearch is a Swiss Army knife for every application. So as you get into a particular use case, it gives you a very defined view of how your observability use cases should flow. A default dashboard to start with, logs, traces, visualizations, services, metrics. Let's start with logs. So if you have a logging use case, generally all your data would be in OpenSearch from your ingestion pipeline. So here I have all my data from the ingestion pipeline as a logging structure. Now, OpenSearch has a language called PPL, which you can use to search through data. It has various different commands that you can use through. From log analytics tool, I can simply say, show me errors in the cart service by hostname. And it should try to compose a query and the relevant data associated with it for me to quickly understand what's going on. Now, this is the basic capability where you can just slice and dice data and view your logs. assume there is a use case. I'm just going to run a preloaded query over here. This query goes through my same OpenTelemetry demo logs. It runs an Envoy proxy. Whenever there are issues, sometimes I don't know where the issues are. And if I want to get a high-level view, majority of my header comes in the body. And in the body, as anybody is building an ingestion pipeline, you don't really decompose every part of the body. It's unstructured data. So if you have unstructured data, you could search with it. But now I want to understand what is the percentage of 2xx, 3xx, 4xx, 5xx, and other values with a success rate with each API coming into it. This is a very difficult query. You might run too many smaller queries as search queries and then try to piecemeal these together. But having this done in a single query, this is where like a power of a log analytics platform comes together. So these are some things you could do with OpenSearch as a log analytics platform. Now, we could visualize how data is moving between geographies. This is a scatter plot showing me quickly how much traffic is moving by errors. So these are like the highlighted parts, these are my errors which are coming between when traffic is flowing between regions. Similarly, I can organize errors, which is a response code over 500, and organize them by average memory consumption with host and agent. Like so, the point over here is to have a logging platform which will give you the base capabilities. But a logging platform cannot tell you things that it doesn't have data about. And that is where structuring your ingestion pipeline is far too important. Now you could go beyond logging. For example, tracing. You have a tracing view. You can facet a tracing view into different services that you want to look into. Some things that logs don't give you, traces are very structured. So you can organize your traces by which service, how the service is connected. I'm just going to reset this to get a larger view. Suppose I want to look at the checkout service, which service is it connected to, its own connected entities. If I'm looking at more services in detail, take a look at the cart service. See the throughput and duration latencies in between here. Go one level deeper, understand all the traces that are happening within the service. For the trace, I can jump in each trace ID, go one level deeper. These are all the tools available on OpenSearch, but they're only powered by the data available to it. Now, here's where the next part of the equation comes in, which is if you have this observability stack, which is powered by everything open source, and you have information available as metrics, logs, and traces, what you don't have sometimes is issues that are real world and hairy to debug. Many of the times, hardware issues with kernels, recent outage or some time ago that happened where just leveling was off on a cluster because of which it wouldn't cool, and all the applications started showing delays and duration spikes, and nobody at the application level layer could detect what was going on because there was no error in the application level layer. But the system level, there was CPU throttling, something with respect to cooling, there were indications. So the point is, if you have an ingestion pipeline, observability pipeline, which does not have kernel level data, you may miss out on major telemetry, which is useful maybe few times in a year. But when it happens, that may throw out your entire error budget. Like that one thing would be responsible for your major outage for the entire year. And that's where eBPF comes into picture. So Pratik will talk more into like how eBPF from a CNCF projects can be tied into OpenSearch, set up and used to debug an entire workflow.
So I guess everyone knows about eBPF, but haven't used it much, and that's the general scene from what I know and talking to people. eBPF stands for Extended Berkeley Packet Filter. It's a really great technology that's stored inside the Linux kernel, which you can use to hook onto the probes, the operating system level processes, and you can use it as a read-only thing to execute and pull out some information from your kernel. Now these, you may ask, like, is it even safe and secure to run these things? Well, to be honest, they are. Every time you run an eBPF program, these are run with a pre-execution check to make sure they don't violate or do anything malicious in the system. Along with that, they also use just-in-time compilation so that they meet the performance throughput. Now, the best part, apart from the basic and highlighty, flashy stuff on the architecture here, is eBPF can be used to get observability data, tracing data, security data out of your kernel maps and kernel stacks. Here in the diagram, you can see eBPF has two-level pieces. The first level is at the user space, where it's running on the application layer. You have your Go programs, you have your JS, Java runtimes, where eBPF can hook onto. Otherwise, the second thing is at the kernel level, where it hooks onto your operating system. And on the next few slides, we'll go deeper into the kernel level part. Yeah. So I guess everybody likes writing their programs in C. I'm just kidding. I see smiles on everyone's faces.
Your laptop is dying.
Oh, it is connected here. Okay, I think there's no power over here. I'll figure it out. You can go ahead.
Maybe I can.
You can go ahead. I'll figure it out over here.
So yeah, we'll go with the eBPF approach with Inspektor Gadget. To the next slide. So Inspektor Gadget is a CNCF project. And most of you might have heard about Inspektor Gadget. This is based on a cartoon where you had a detective who had lots of gadgets in their arms and heads. You would have a helicopter underneath his hat, and he would solve cases. Similarly, Inspektor Gadget, the CNCF project, is an open source project where you have multiple gadgets. These gadgets are nothing but eBPF programs that run at the kernel level. But the best part about it is you don't have to write anything separately, as in the C program that I talked about. You can just execute it in a container level environment. And the second good part about it is everything can be exported in OpenTelemetry format as logs and metrics. So if you have an OTel collector, your eBPF program's outputs can be directly sent to your vendor-specific thing. Or the best part is if it is open source and it is using OTel, you can also switch your backends for whatever OTel metrics log storage you are using. Also, it has ability to send out OTel metrics to Prometheus. Prometheus recently added their OTel metric support. So this is how we enable eBPF data being sent to OpenTelemetry storages and everything keeping open source in check. Now, what's the best part about Inspektor Gadget at a container level? I don't have to run these programs separately. I can just run this as one container running in my existing setup. So this is the same OTel demo architecture that we saw earlier, where you have microservices sending out instrumentation to OTel collector, which internally sends your data to data prepper. And then data prepper stores your logs telemetry data to OpenSearch, and finally you visualize in dashboards. Here, as a sidecar, we have added an Inspektor Gadget in the initial link that we showed on the slide, where in my Docker Compose, I have 3 processes that are running on Inspektor project. So if we go to the next slide, these are the 3 minimal Docker Compose files that I've written down. One is for CPU profile. So every container will have a set of CPU processes that are running. Inspektor Gadget will hook onto these processes, give me the kernel stack output. For checking for out-of-memory issues, I have a second gadget, which is the trace out-of-memory kill. It will give me the trace output of the kernel stacks of every process that is being killed by memory issues. The third part is trace TCP. TCP, as you all know, will give me the source and the destination part of each process being talking to the other one. And that map is what is stored in OpenSearch. from a flow point of view, how the data is moving. These gadgets sent out the OpenTelemetry data to data prepper. Data prepper stores it in OpenSearch, similar to the previous diagram. And finally, we visualize it on Discover with new PPL commands that Ani was showing earlier. So this is our setup stack. Now we can jump on to the actual Docker Compose itself. So along with my hotel demo Docker Compose, which has these multiple services that are running, I add this one for the CPU profiling part. So if you look at the command that I'm running here, under the command you can see run profile CPU. That's the trace, that's the kernel stack gadget that I'm running. It will hook on to my CPU profiles on all the containers that are running in parallel. And for individual container, it will give me hotel logs, which will be nothing but the CPU profile. Now, the another part that I like about Inspektor Gadget is you can annotate whatever logs it is emitting out. So this will come up with the container runtime process details, such as what is the container image ID, what is the container name itself. So I know when I explore it in my logs, I can just write container name is equal to add and easily filter out these logs. And then we can go to the next slide. Yep. So right here, let's come to the real issues now. We have talked about demo environments and everything, but how do you use these eBPF programs in real life issues? To mimic these scenarios, OpenTelemetry demo has feature flags, where you can enable a feature flag and it will mimic a scenario that you see in the real world. For this particular issue number 1, we are using the feature flag from Hotel Demo for add high CPU. So add is a service that's running in our Astronomy Shop website, which gives on ads on the latest telescopes that are available. Now, if I enable this, internally Hotel Demo runs a program that will mimic a high CPU usage. Now, if you look at logs in general, you wouldn't see any high CPU issue there. Logs would be just emitting out the regular things. There's nothing related to high CPU. But if you go deeper into metrics, you'll surely see a high CPU measurement on your container runtime, and you know that there is something wrong. eBPF goes one level below this and also tells you what are the hot threads running on that particular CPU. So it's not just giving you the metric, but also going one level deeper to know so that you can match it to your program and see if it makes all sense and there's no malicious code running. So for this setup, I use the profile CPU gadget that we initially set up. And here's the sample visualization that I created using Inspektor Gadget data, sending OpenTelemetry logs with the CPU profile instrumentation scope. So if you see, I'm not sure if it is visible, but the instrumentation scope is set by the gadgets that you're using. We use CPU profile, and that's what I use it for filter. I use the body match function to see if there is any kernel stack being printed out or not. The match is a full text search command in PPL. Sure if you have to leave out. Okay, you're back.
Back to scheduled programming.
I think so, yeah. That was the CPU heating up the building, I guess. Yeah. So after doing my match filters, I only look at the container names that I want to focus on. I don't want OpenSearch or any other monitoring stack in my Docker environment coming in here. So I restrict it to these services. And finally, I use the stats command in PPL and create a metric from my hotel logs that are coming from eBPF programs. So here in the visualization below, you can see the CPU usage of every container that is running. And this is what we'll use as from our dashboard for seeing the high CPU usage. Now, if you see with the flag enabled and disabled, you can see the clear difference. When the flag was off, all the processes similarly had like 5 CPU cycles with their threads, and there's no anomaly here. As soon as I switched on the flag, I can see the add service actually saw a shot up in the hotel logs, and we can see it clearly in our logs to metrics visualization. At the same time, in CPU profile, you will see the exact kernel stacks for add process that you're seeing. So now we can go to the next level of using the stack information and seeing what's the actual thing that's causing the high CPU. So from the OpenTelemetry demo feature flag, what they have done is to enable and mimic this high CPU scenario, they have created a while loop, and inside that you have a matlock function for your time. And this runs infinitely as long as the feature flag is on. So that's what enables the high CPU usage. And we can see from the kernel stack that it is 1:1 relatable. So that's the extra information that you get from eBPF programs. You don't just rely on a metric, but you also know the root cause from what you got in hotel logs. Now let's jump on to the issue 2. Here we have a cache miss scenario. We again use the hotel demo feature flag, where I switch on this flag where recommendation service stops using the Valkey cache and stores every recommendation in the memory. Now, what this leads to is, every time a recommendation is put out on the website goes, the recommendation service goes down, and it leads to an out-of-memory kill. Now, as I mentioned earlier, we have that out-of-memory gadget that we use. So we just use that here and try to see if that can help us get this issue and root cause this issue further. So here's again another logs to metrics visualization, where I use the service name as Inspektor Gadget, and my instrumentation scope is out-of-memory kill. That's the gadget that we are using to create these logs. And again, I restrict it to the container names I want to look at. And finally, there's a stats command to aggregate my metric by time span and by container name. I see whenever I switch on this flag, all the OM kills I see is for the recommendation service. So that's how you can use logs to metrics with Inspektor Gadget. And this, if I know my application really well, I kind of get a hunch that it might be missing the caches. It's not going into the root cause completely, but you get a high-level information from your kernel-level data. Moreover, you can also get the PID, the child process ID, and other stuff that you might require to see if it is a process memory limitation, a container memory limitation, which you might not get usually with Kubernetes logs or runtime environments. So let's come to our final issue. I talked about a lot of resource issues, but what if you tell me I just don't want to look at these CPU metrics, I have other stuff for that. I just need a regular metric to see what is the footfall on my website. OpenTelemetry demo has a good load generator. It uses locust to mimic people going onto the website. So we switch that on, and we use the Inspektor Gadget's TCP traffic gadget to know what are the IPs being hit by what processes, by what containers. And if we go to the next slide, we'll see, again, a new metric here, which is using trace TCP as my instrumentation scope. And this uses source and destination to be mapped and finally used as the metric here. I put a where clause for the container name to make sure that to check my footfall on the website, I only look at front-end proxy, because that's the one where every request comes to from my website. And this is the regular metric. It's count by your time, and that gives me the footfall. Ideally, you would go on and add unique IPs, do some deduplication on the people commands, but because this is a mimic scenario, you don't have to do that. It's just giving out the regular usage. Yep. Now, let's go to some live dashboards. Here, these are the same commands that I used earlier in my slides, but I'm giving you a live view of the actual JSON output that we see from Inspektor Gadget. So you see the log attributes that are coming in here are coming in from Inspektor Gadget, annotating my kernel level data to show what is the runtime where the process is running, and also the container name. Now, also, if you look at the resource attributes, you'll see the host configuration, the type of operating system, and finally in the body, you see the actual CPU kernel stack that led to the hot threads. I jumped onto the visualization. This is the visualization that we saw earlier, where you could use the kernel data and create the CPU usage visualization. Yep. Same thing for the website footfall metric that we created, where you could see the front-end proxy's IP being hit here and seeing it as a metric. Finally, this is the dashboard that I created just using OpenSearch, Inspektor Gadget, and PPL. So these are the only technologies that are used here. And you can see out of these 3 technologies, you can create a lot of resource intensive jobs into a simple gadget command and finally create a dashboard out of it. So you don't have to write your programs in C. You don't have to manually add your resource attributes. Inspektor Gadget will do most of it, and dashboards will do the heavy lifting of creating these visualizations. Back to the slides. Oops. Yep. So what are the key takeaways from our session today? Logs, traces, and metrics are still needed. You cannot do without them. But eBPF creating this telemetry data is a good addition to your existing monitoring stack. You can use that QR code to go and look at my demo itself. You can try it yourself. It's there on my fork in the Inspektor Gadget branch. Also, coming on to using Inspektor Gadget, what I felt personally and saw it was, it's not a replacement to your existing monitoring stack. It is a good add-on. It will give you a lot of benefits which you don't get in terms of the resource attributes being added in. And finally, the new OpenSearch PPL and Discover experience makes it really easy to create these dashboards out of box. I have some shout-outs before we end the topic for today. Observability tag for OpenSearch just came out, and we did a kickoff meeting last week. The meetings are open and public. If you want, feel free to join. This will help us guide how OpenSearch and observability takes place in its future and give a better guidance with the community. You can check out the observability Slack channel on open source Slack, and you will see more updates on the meetings and next invites there. We also have a session on new Discover experience and PPL. How is it being rolled out in OpenSearch 3.3? And please join our peers who are presenting tomorrow at 12, and this is in the gold breakout room. So that's a good one to attend. And that's what we had for the demo. Thank you so much. We are open for question and answers. I'm not sure of the time.
Yep.
Yep, we still have some time.
Have you ever seen ground cover? It's a framework for observability based on eBPF.
I haven't seen it. Yeah, so you're talking about ground cover. Okay. Okay.
They're actually positioning pretty fast on the right.
Mm-hmm.
They're literally an eBPF framework that is, of course, having their own internal solution and their own pipeline, but it's based on same premise.
I see. Okay. It's pretty cool and interesting. We have seen multiple of these extra tools that come up, but only thing we are seeing an issue is with the long-term support. We had the Hotel eBPF collector as well, but it didn't pan out as what we thought about it, and it's being deprecated. They're coming with the new stuff that others are providing. So it would be good to try it out. I'll take a look for sure. Yeah. Yep.
So for your first use case, is the log committing a CPU profile and how long it took for that process?
So that was just the kernel stack being sent out. And based on the kernel stack, I just counted the number of cycles that is going through and then created that metric.
Is that for every request or like do you sample?
So OpenTelemetry, Inspektor Gadget doesn't sample by itself for logs today. It does for metrics. But you can do the sampling at the hotel collector itself. So once you get the hotel log from Inspektor Gadget, you can change the hotel collector configuration to sample it out and remove the events that are not needed, or even do some aggregation in the processes there.
Is it possible to use OpenTelemetry to monitor OpenSearch without
Today, yes, there is an experimental plugin that we have in OpenSearch called, I think it's called OpenTelemetry or something in that sort of thing. It's called OpenTelemetry framework. So there is an inbuilt plugin in OpenSearch. It's still experimental, but you can send out OpenSearch metrics directly to OpenTelemetry Collector out of it.
Is there a plan to use hotel receiver development under OpenTelemetry? Because actually it's missing there. There is no receiver.
I see, yeah.
They are asking for a sponsor.
Mm-hmm.
Are you part of that committer who can sponsor?
Yeah, you can send out the details in the observability Slack channel, and we can surely talk to the stakeholders and see if we can sponsor that. But that's like OpenSearch receiver for hotel, right? I see, yeah. Yeah. That's a good one. I didn't know about it, that people are looking for that. Cool. Any other questions? Cool. If not, I think we are good. Thank you so much for joining in.
Thank you.